It's almost like that little Spider-Man cartoon where like the three Spider-Mans are pointing at each other like, wait, you're supposed to do something. And it's not a really good feeling when people are coming into your space and you don't actually know what is going on. Welcome to Lean by Design podcast. I'm your host, Oscar Gonzalez, alongside my co-host, Lawrence Wong. We are former MBA classmates turned business partners with over 25 years of combined experience in life sciences. From R&D through manufacturing, our experiences have shed light into the complex, ever-changing challenges experienced by this industry and many others. We took a risk, quit our six-figure paying jobs in Boston, biotech, and pharma to start Sigma Lab Consulting. Journey with us as we explore the relationship between people and workflow design. The goal? To learn, inspire, and deliver practical tips to navigate these ever-changing challenges. Stick with us and learn to work smarter, not harder, and be lean by design. How would you feel if you learned that unplanned equipment downtime can cost companies upwards of $260,000 per hour, according to some estimates? This alarming figure serves as the backdrop for our conversation today about the intricacies of equipment maintenance and servicing in the life science industries. The dialogue goes beyond merely troubleshooting mechanical issues to explore the overarching system of communication, responsibility, and planning that constitute a well-rounded approach to equipment care. The discussion illuminates the collaborative roles that equipment owners and service teams plays, each with distinct responsibilities, but united in the quest for operational excellence. And welcome back to another episode of Lean by Design podcast. Oscar Gonzalez here, my co-host and biotech manufacturing facilities extraordinaire, Lawrence Wong.
What's up?
Welcome. So we get into facility, giant, when I think about facilities, I understand there's a lot of facilities that can either manufacture compounds or drugs or what have you. And in my mind, for some reason, I get this idea of like a giant brewery that just has giant tanks all over the place.
That's pretty accurate.
So, either way, I think this is going to be good for a lot of our listeners. But, with all that equipment, who's really responsible for managing that? How do they go through that equipment and go, okay, well, this is what we need to do? Because I know very well the risk, the inherent risk that if something goes wrong, what that does to a full production line. If it's contamination, if it's a piece is broken, what that does to have to shut down, to repair, to fix. How do folks now go through all the equipment that they have, that now in some of these large organizations is in the thousands, and make those preventative measures and be able to schedule the right work that needs to be done in the right place? I mean, what do we do?
Yeah, so usually you'll see what they call an asset management function. And so what that function does is they're responsible for any of the maintenance and calibration of your systems, equipment, instruments that either fall into like a utility category, or maybe it's something to do with HVAC. It might be something on the manufacturing floor. It might be something in the lab. But depending on the type of work, there are specific, I would say, service providers that are responsible for providing that care. So for the purposes of the discussion, we'll just focus on scheduling routine events, right? So I think when you talk about non-routine events that are unplanned, like the emergencies, there's usually not some sort of like blanket cookie cutter way to do things, because it really depends on the criticality of the system and the severity of the incident, right? So as an example, if somebody is seriously hurt, obviously, you drop everything and you go address that immediately, versus, hey, we have a slow drip. And it's like, okay, well, how bad is it? And then what is leaking? If it's like the toilet, then maybe we don't address that immediately and we go do other things, right? So it depends on the asset criticality and the severity of the failure. So when we talk about maintenance scheduling and asset management, I want to start with addressing about how things shouldn't be done. And so
this is
a
going to
lot
be
of
good. Can't wait to hear these
most
stories.
companies are going to operate out of a computerized maintenance management system. And so all that is it's sort of like a ticketing process where every month you'll have, a set list of work orders that you have to address. So those work orders might range in doing maintenance on a pump, right, where you have to replace a seal. It might be calibrating a temperature transmitter that's a part of a freezer. And so all of these routine events, they usually, they're usually due at the end of the month, and they'll come up maybe a couple days before the next month, but you'll get a list of things that need to get done for the next month. And so what happens is the planner will either have a meeting, or you'll send an email out and say, hey, I need a bunch of availability for your equipment so I can work on it. And so if you're the owner of it, you'll come back with a bunch of dates, or you'll say, this time works for me, this time doesn't work for me. And then that bundle of time and dates gets forwarded to the service provider. And so then they'll look at their workforce and say, this either works or doesn't work. And so this happens a couple more times until somebody waits at the last minute to schedule the work, and it's due in a couple days. And so that's just for one job. Awesome. You can imagine that if you have hundreds of work orders, how infuriating this is, because you waste so much time just with emails and meetings and getting dates and times. And so, what do you do as a planner to improve this process and make it a little bit less painful? It begins with setting expectations and communicating with the stakeholders, right? And so I'm not talking about from job to job, but overall strategy. So suppose you have a lab group that has a very front-loaded schedule in the morning, right? So they do most of their experiments in the morning. In that case, the afternoons are probably the best time to do the maintenance because there's less activity going on. Another Makes scenario sense. Might be, hey, this job impacts your most critical instrument, and so you're not going to have this available for you while we work on it. It probably makes more sense to assign the most experienced technicians to service this so you can get it back to the owner in time, right? You don't want to be assigning a bunch of rookies to service this thing, because if something goes wrong, then there's a lot more impact that will create on your schedule.
Are these internal people that we're talking about here, or from the vendor?
So it depends. So your calibrations, depending on the type of equipment, might be internal or it might be external. I find that if you are dealing with external partners, they're usually a little bit more accommodating than your internal partners, just because when you bring things in-house, there's just a lot more responsibility and a lot more equipment that they have to take ownership of, like as they're servicing them, right? Whereas a service provider, it's like, this specific make and model is serviced by like one company versus, this internal team that has to service like hundreds of different types of equipment and instruments.
And do you see the level of complexity changing? So it's usually these more specialized, complex items are not handled by the folks that are working in the organization. Is that a fair statement to make?
Yeah, so I would say for the most part, the more complicated the instruments are, the less likely it is to be owned by an internal team, just because a lot of these vendors have proprietary software, or you might have to have a certain level of access to alter some of the configurations within the instrument to be able to do certain testing. Now, I believe the opposite may be true for the maintenance part of it, where if you have a very complicated water system throughout the building, that's usually not fabricated by one vendor. It's usually what we call a stick-built system. And so that usually means it's a mixture of all different components from different vendors. Like you might have a pump made from somebody else, and you might have a valve made from somebody else. So in that case, those components tend to be, like individually, they're not as complicated, but the system as a whole is complicated, right? So if you can think of a water system, when you have to replace things like gaskets or O-rings, you have to drain the entire system. And so you're not going to have a vendor that does that work. It's going to be the internal team that's familiar with the automation sequences and like how to go about locking things out and draining the system. So that gets a little bit more complicated.
Like you have to prep, you have to essentially do all the prep work prior to anyone coming in to fix or replace a certain piece.
Exactly. And not to say that you don't have to do that for instruments. You still have to do that in some cases, right? So a good example is if you have some sort of like caustic tank, that has a very, I would say, dangerous or potentially dangerous solution. You might want to outsource that to maybe a Clean Harbors or some other company that's more familiar with handling those types of solutions. But from a scheduling perspective, you'll usually have like a high level scheduler that assigns like time slots to when things are going to be serviced. And then once that happens, there's an assignment that happens, right? So the work order record will have somebody that's assigned to it. And that means that there's an individual who is the lead for that job.
I see.
And that's not to say that, it's just one person working on the job. It's just that they are the person responsible for communicating any delays and sort of leading the execution of the job. They're the project manager, but they're also the ones that are executing the job as well, right? Like they're using certain tools and standards to kind of execute on whatever the job scope is. Now, when you look at stuff that is maintained externally by like a service provider, that may be through a vendor or supplier that's outside the company, I've seen it handled a number of ways. It usually comes down to like whoever owns the contract, and that may be the actual equipment owner, or it may be the facilities team that owns the contract. But whoever is owning the contract is responsible for overseeing those resources that are coming in to service the equipment. And there's a bunch of liability that happens if that's not structured correctly, right? So if you don't own the contract, but you're giving the responsibility to somebody else, they may not be familiar with the terms of the contract. So I've seen this happen where facilities will own a contract and then they'll say to like the lab owner, hey, like, we pay for the contract and you can schedule so-and-so to come in and work on this. Aim of unexpected findings or delays is extremely important, right? Nobody wants to hear that the system or the equipment being handed back to them is going to be delayed a couple hours because you have all these experiments and all these production activities that are scheduled around you completing your job on time. And so I've seen instances where people get close to the end of the job and they go, oh yeah, we need to replace this seal, but we won't have it for a couple of days. And it's like, why didn't you tell me that earlier? Because I have a group of people that are waiting.
Why did you even show up to do half the
exactly
job?
Right. And that does a couple of things. One, it not only puts pressure on your schedule for completing those activities that you had planned, but it also creates this like sour taste in the equipment owner's mouth, right? Where they're like, why didn't you tell me this earlier? Because now I have other responsibilities that I have to tend to because of this delay, right? And I'm not saying that these things don't occur, but the more upfront and transparent and earlier that you can tell somebody, the more time they have to plan for an alternative strategy. If you're waiting till the very end, chances are your equipment owner is not going to be very happy with you and all the other jobs that you have planned for that system, right?
You're listening to Lean by Design podcast, and we'll be right back after a quick break. Do you suspect your life sciences company could do things more efficiently? Maybe you're seeing costly workflow issues, or maybe the work feels more difficult to perform than necessary, affecting team morale. If any of this resonates, reach out to the team at Sigma Lab Consulting for a free consultation on how we can develop and launch a custom solution fit for your team. Our consultants will build a custom workflow solution for your team to reach peak efficiency. Find out more at www.sigmalabconsulting.com.
Once you've completed the job, one of the other things that people tend to miss is ensuring the system is returned to normal when you return it. That doesn't mean
you're supposed to test it, right?
Yeah, you're supposed to test it. That doesn't mean pack up all your things and leave and then send a phone call and go, oh yeah, everything's all set. It's you should be doing a quick walkthrough with the owner and doing like a quick check to make sure everything is back to normal and there's no problems before you walk away. Because I've seen times where a
Who
system will
who
get.
owns that? Who owns that? Should I basically tell somebody that comes in like, hey, like, are you going to show me or talk me through what you did and show me that this is still working? Is that, or should we feel that whoever comes in to run that servicing, that should be part of their process?
It should be whoever's coming in to do the servicing to communicate with whoever the owner is. Is there anything that we can do to test the system to make sure it works? Because there are a number of pre-use checks that you can do on any benchtop, instrument. There might be like what we would call like a leak test that we do on certain tanks, or maybe piping to make sure there's no leaks. I've seen a bunch of times where somebody will walk away, they put water in it and they go, oh, it's leaking. And it's like, now we got to open up another work order and now I have to allocate more resources to fix it. And it's like,
and I got to call them back.
Right. If you would have just stood there for an extra 5 minutes, you would have, prevented the amount of work order and documentation that is needed to kind of address the issue. So yeah, please remember to return the system back to normal, because nobody wants to put in another work order just because they allocated you time to fix it anyway, because you're creating more work, right?
Right. It's like coming and changing your printer cartridge ink, taking it out, sticking it in there, closing it, and going, all right, it's done. Well, why don't you take a test page to make sure that it's actually printing ink?
Yes.
It's obviously a more complex space that we're discussing here, but it makes complete sense to me. You take your car to the dealership. What happens? They fix it. They take it for a drive. Then they come back. Yep, we're good. They don't fix it and go, all right, take off. And then you take off and you hear the squeak, 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 squeak. You're like, okay, they didn't do anything.
Yeah, and if they are doing that, like, that's red flag number one, is you should probably go somewhere else, because you want to have those quality checks in place to make sure that you're not in any sort of danger to yourself, right? Because there are systems that are dangerous, and turning it over and turning it on immediately, there are a lot of risks associated with that. But there's also a business impact, right? Like, nobody wants to have additional delays when we've already set a time, this allocation of resources to perform maintenance. And so, my last point here is really, any feedback that you have during the execution of the work order should be documented so that you can make any incremental improvements to the job duration, the scope, the training, maybe the parts that you need to stock. And without having that feedback logged, nobody has any idea of how to make anything better. And this is why it's so important to keep these, I would say, but it's both qualitative and quantitative feedback. So you have like these job durations and I would say hours and money spent on a work order, but you also have feedback from like, hey, the technician thought that maybe the equipment wasn't handed over properly and the area wasn't clean. And, there are just small little things that we can improve on over time, but without them putting that in the work log, nobody has any idea on how to improve those things.
I mean, just think about the equipment and the information, and what happens when you take it to like the take your car to the garage that you always take it to. They pull up your specs. They pull up, oh, these are all the instances that we had, et cetera, et cetera. I can imagine that it's very valuable to have that information, not only for like new people coming in to say, hey, you're going to be the new owner of these systems. Here's the logs that we've had for the previous returns. And they might look in there and go, wow, do you guys realize like in the last 3 years, you've replaced this component 3 times and that's supposed to last 10 years? That's something that is like, okay, so how do we now affect that so that the downtime shrinks? And this is, again, one of those examples of just seeing something and saying something, not just going, oh yeah, they replace it every 3 years. Is that normal? Or every year? Is that normal? Is that something that's supposed to happen? If not, maybe we ended up with a lemon, or maybe they changed the design of the gasket that they're now putting on this piece and it's more brittle, or, understanding those pieces of equipment and having that documentation is super critical to really continuing on making sure that the facilities and the equipment has very little downtime, because I can just imagine from the perspective of operations for that a particular group, no one wants that stuff to be down where they can't use it. I've been at an organization before where we had basically two very highly used pieces of equipment. One went down. The other one was like a 3 years older version. So we weren't getting the same resolution that we had on the equipment piece that went down. I don't know where we were with yearly updates or yearly, you go get your oil changed, you go get your tires rotated, you go get your tires filled in. This is the kind of stuff that you need to do when you're dealing with equipment. You need to take care of that equipment if you expect it to actually last. The reason why they give you these, these long durations of lifespans for these pieces of equipment, and why it's very closely captured in the 10K of organizations. Where are the assets? How have things depreciated, et cetera, et cetera? The only way that they're going to last that long is if you actually take care of it. And the only way that you're going to ensure consistency in the product, in the testing, in the mechanisms, is to keep these systems up and running. I came from a place in academia where equipment was, it's pretty good. Okay, well, I hope we're not planning on, trying to get grant money with data that is not very accurate because none of our pipettes have been serviced in 4 years. And some of those really, and it's a very simple thing, but a very common instrument is that pipette. And let me tell you, the differences that you see in that pipette, they're not always due to the types of tips that you have in there. A lot of times it is that calibration. There's, some grease that needs to be applied. There's some, those things, they're going up and down. Oh, my thing squeaks. Yeah, it's no big deal. And then it gets stuck, and then you start sucking things into your equipment. Mm-hmm. Now you can't even use it.
Yeah.
It's like, oh yeah, I've had this noise, going on in my car, and then all of a sudden, pow, you're stranded in the middle of the interstate.
Right. And I think from a scheduler perspective too, and I'm not saying that the ownership completely falls on them, but having an understanding of how critical these pieces of equipment are to not just the owner, but also understanding the impact of the work that the maintenance is providing, right? So, what is why are you calibrating this? What is the value of it, right? Once everybody's kind of on the same page, then they understand that this activity is crucial for you to, leverage any data on for your experiments or anything that is in the process that relies on that measurement. You can say that it's accurate and it's precise because of those calibration activities. But if people don't value those activities and see that as a value add, then they're not going to take it as seriously, and you're going to push off maintenance. You're going to say it's not important. You're going to find ways to justify why you don't need it, and you're going to start cutting corners. And all that's going to result in is compromised data and your process, right? That you can't rely on.
Absolutely.
We'll be right back after a quick break. Is your team constantly fighting fires? Are you struggling with productivity and think it's due to inefficiency in your operations? These challenges can be difficult to measure, but not impossible. Sigma Lab Consulting can help you define and prioritize the issues that are negatively impacting your team. We partner with stakeholders to redesign workflows so you can work more efficiently. Find out more at sigmalabconsulting.com.
So I want to kind of bring one last point, and it's about, if you want to improve scheduling, whether it's external or internal, you have to have a working relationship with the owner of the equipment, but also the service team. I've seen too many teams be completely reliant on the system owner and just have them dictate how things should go. There are other people involved in this, and it's the actual people that are servicing the equipment and the instrument, right? You have to consider that as well. Right. Because things happen, and you need to be able to have those communication channels open. If there's an improvement that they see that the system owner doesn't see, they should be made aware of it, right? And it goes the other way around too, right? If a technician is working on a piece of equipment and the system owner has noticed maybe some abnormal findings in the last couple of days from when they were running it, you should tell the technician to hey, be careful. This thing, maybe there's, some sort of dangerous part of the job that maybe you didn't consider, right? One of those things might be, hey, this valve is leaking, or this thing is really hot next to it, or something like that.
I was going to say it got hot, or like it started to smell like something burning, or it smells like metal all of a sudden, something scraping itself, or
right. Because at the end of the day, nobody wants to come into work and leave with knowing that the job was done in a poor way, and nobody wants to leave hurt. Like, everybody wants to come in and do a good job and to go home safely. So, keeping those things in mind and making sure that all parties involved are aware of what's going on will drastically improve how you not only schedule your routine work, but it makes it easier to work on those emergencies, right? Because you don't want to be building a relationship with somebody on these very high tension, high pressure jobs. You want to slowly build that relationship over time on these simple routine activities, so you can have that dialogue and build and build and build and build. And so when you face this challenge together, you're not questioning whether or not that person's capable of handling it, because you've had this relationship with them over time.
Right. It also gives you that second look at something, whenever, regardless of where the process improvement is, it's imperative to really develop that relationship with people that own the process or own, the product or the equipment owner, and those that intend to really apply a fix to it. Sometimes it's the same person, but oftentimes you do have to engage with external people. I mean, if I'm improving my own process, then it's my own process for something that I'm doing. But oftentimes these things that we're working on, the reason why we're working on them is because they affect multiple people. And if we don't have the relationships where we can feel compelled to, give them information, hey, this just happened last week, or hey, this happened, at some other time. And, at least having somebody there that has the expertise to really drill down into that piece of equipment, and have somebody that's there that, as the product owner, you're also speaking for everyone else that uses it. You're speaking for everyone else. You are the beacon, the connecting piece between the service contract owner, vendor, and the organization. Who's using it? What's happened? What have they noticed? So it's important to really understand that, because like you said, no one wants to go to work in biotech or science that has challenges, because there's so much we don't understand. No one wants to go into there and spend hours getting something ready and then using a piece of equipment to find out that something happened and we could have that was preventable. Preventable maintenance. It's insane how often those errors do occur. I've had many times where I've had my protocol is 6 hours of preparation. And then boom, at the very end, I find out that the pieces of equipment have been down for 2 days. No communication, no announcement, not even a piece of paper on there. It's just unplugged. Why is this unplugged? Oh, it hasn't been working. No one thought to say anything to anybody about this. We have become such a society, I think, in the professional landscape, where we just wait for people to give us information. We don't seek information, and we don't push information. Whether or not it's in the space of equipment maintenance or in the space of running projects, you have to learn to engage in a push-pull relationship with all of your stakeholders. Not any one person is going to be able to connect the dots from end to end in any process that involves multiple stakeholders. 1,000%. There's always something that somebody else is doing into that workflow that you have no idea about.
Yeah, and
you may know that it exists, but you don't understand the nuances of it. You have to have those relationships.
Yeah, and you brought up the Spider-Man meme before about like the 3 Spider-Mans like pointing at each other.
Yeah.
You don't want that to happen if there's a fire going on and there's a true emergency, and you don't want to be pointing fingers at different people like, oh, that's your problem, that's not mine. And you want to be having 3 Spider-Men, like, saving the city, right? Like all 3 working together, knowing, hey, you take that portion,
I'll take care of this portion. This one's going to go notify everybody. This one's going to get a report going, blah, blah, blah. I'll stop the bleeding.
Exactly.
figuratively speaking.
Yeah. And
That's critical.
Yep.
Use your stakeholders, build that team. And it's not even necessarily a physical, I guess you could say a formal team. Build those connections. Those people are the team that you could count on, that you could talk to, that will give you that information, will give you new information.
Yeah, and this is a very similar theme to the our previous episode is these I would say gaps or maybe bottlenecks that you see in your scheduling process. They are opportunities for anyone in those within that team to take ownership of driving those changes and to make it a little easier on the next job and the job after, to be able to schedule these key activities across not just your system but everybody else's system, and it just gives you the opportunity to take responsibility for other higher level planning activities or maybe projects even.
I agree. I could not agree more. It's a lot of opportunity there, a lot of coordination, but all it takes is to get started. I think some people are a little afraid of just like, I don't know where to start. I don't know who's involved. I don't want to step on toes, and the old added, it's not my role. I think we need to start getting out of that mentality and, not being in a role versus, hey, yeah, let me help point you in the right direction, or let's take care of this. I can show you what this looks like so that next time if you run into it, you can solve that. Again, just what we talked about in the last podcast episode, educate folks. Don't just necessarily do things for them or do things that, somebody asks you, hey, can you do this? They're asking you because they know you're capable of doing it. They may not know how to do it. Form that team, form those stakeholders, educate people, give information. Don't just take it.
Yeah.
We love to just take information and we hate to take the 2 seconds to give it.
Right. Yeah, absolutely.
So Lawrence, been a fantastic conversation. I am, you got my wheel spinning. And there's been more than one occasion. And just for me, from the laboratory side, seeing things that just all of a sudden, this is down. I've been part of organizations where their operations managers do a fantastic job of notifying people when the fix is coming, who's involved, when it's going to be fixed, and then that it has been fixed. And I think it's really that transparency that we talked about, and really, involving all of the stakeholders, because you don't actually know how much that piece of equipment or machinery, et cetera, needs to be used in the next couple of days. There may be some big experiments that you're not accounting for, and you need to make sure that you're giving people the right amount of time if they need to connect with another sister organization, or, oh, I know they have another one on the 6th floor. I'll see what their schedule is so I can go upstairs and use that piece of equipment while this one's being fixed. It's all this transparency, education. That's really key to working smarter.
Yeah, I think you're absolutely right. And whether you're in a lab setting or a manufacturing setting, the planner acts as a project manager, not only for managing the work that is being performed, from a service context, but also from the point of view of you're orchestrating the relationships between these different groups and having to complete the maintenance on time, within the specified duration, and ensuring the system gets turned over, back to normal state. So a lot of similarities, whether you're in either setting, and it just shares a lot of parallels with managing projects as well.
Yep. And I'm going to keep using that example of a car. No one is more upset when you go in for an oil change and they tell you that your tires are flat.
Yeah.
I've heard so many times, I go in there for this and they tell me that. How upset would you be if you went in for an oil change and they didn't tell you any of that? That's when that's a problem.
Yeah. Yep.
Lawrence, thanks again. And to those listening, we appreciate you following, and be sure to share, hit the like button, share the podcast out there. We're going to keep coming out with new episodes, really bringing you guys a lot of experience from Lawrence and for myself, what we're seeing in the industry and how we can improve the processes to really make science and biotech more efficient and more lean.
Yeah, awesome. And as always, work smarter before you work harder.
That's right. We had some critical learnings in today's discussions. Firstly, the importance of clearly dividing responsibilities, which cannot be overstated. Knowing who is accountable for which aspect of equipment maintenance, whether it's the end users or the servicing teams, truly sets the groundwork for effective action. This helps us avoid any overlap or gaps that could lead to inefficiencies or even failures. When we discuss proactive maintenance, the concept here is simple but powerful. An ounce of prevention is worth a pound of cure. Scheduling regular checkups and maintenance activities can save a significant amount of time, effort, and resources compared to the reactive approaches that only deal with issues as they arise. Regarding communications, this involves more than just giving orders or sending emails. It's about fostering interdisciplinary dialogue between different departments, maintenance teams, and vendors. Without clear communications, even the most well-planned maintenance activities can come to a standstill, leading to avoidable delays and expenses. We can't forget about documentation. It seems tedious, but keeping meticulous records of equipment history, repairs, and inspections creates a valuable repository of information. It not only helps during troubleshooting, but also makes it easier for future maintenance of activities to be carried out more efficiently. Lastly, but not least, a holistic approach to equipment care is essential. We're not just talking about nuts and bolts here. We're discussing the integration of processes, peoples, and technologies. When these elements work cohesively, it sets the stage for operational excellence that transcends individual tasks or departments. Thanks for listening. Don't forget to leave us a review, like, and share on Spotify, Apple, and Google Podcasts, or wherever you get your podcasts. And if you're interested in being on the show or becoming a sponsor, send us a message at leanbydesign@sigmalabconsulting.com.